Now let me just explain this code. Let me start from main. So in the main code, you see I have created two tasks. First task name is task 1 and second task name is task 2. Task 2 is of higher priority 3 and task 1 is of lower priority considering task 2 and its priority value is 2. After that, let's go to the task 1 handler, and in the task 1 handler, it actually toggles the red LED with 100 milliseconds duration. So I have used HAL underscore delay, which is while loop based, to make it this as a continuous task. And task 2 handler executes toggles the green LED with a duration of 1 second. And they both call switch priority function. Switch priority function is right here. Here what it does is it first checks the button status. So button status is a flag. It's a global flag which is modified by the interrupt handler, button interrupt handler. Currently it is set to 0. Whenever button interrupt happens, this variable will be set to 1 by the button interrupt handler. Button interrupt handler is right here. Button interrupt handler, it just makes status button is equal to 1. That's it. Since it's a shared resource, because both task as well as interrupt handler, they try to change this variable. That's why this is a shared variable. So that's why I have protected the access to the shared variable using these macros, enter critical and exit critical. Enter critical actually disables those interrupts whose priority is less than the configuration macro max is called priority, isn't it? So here the interrupt will get disabled, and after that we manipulate this global variable. If the status button is really set, then that means the user has pressed the button. So the status is actually made as 0 here, and this flag is set to 1, and after that exit the critical section. The interrupts are re-enabled, and after that this flag is really set. That means we have to carry out switching of priority values. First, what I do here is I get the handles, task handles of both the task using this task control API, or you can call it as task utility API. This API can give you the handle of a task by taking its name. Here I get task 1's handle and task 2's handle, and after that using those handles I access the priority values of both the tasks. So I save it in P1 and P2 variable, task priority get. So for the task priority get, all you need to provide is just the task handle. And after that, I want to know which task has called this switch priority, because switch priority function can be called by both the task 1 and task 2. Here I want to know who called it. For that I can use x task get current task handle, and I save it in a current variable, so which is nothing but a variable of type x task handle. And if task 1 has called it, if task 1 has called this function, if that is true, then first I modify task 1's priority value using the priority value of task 2, that is P2. I reconfigure the priority value of task 1 with task 2's priority value. And after that, here I configure task 2's priority with the priority value of task 1, like that. Suppose if the current task is T2, then this code block will execute. Here I first modify T2's priority, and then I modify the priority value of T1. This is very simple. So now let's check the Sega System U trace. Here at these points, the application actually received the interrupt. So now let's first check where exactly the first interrupt happened. I can use this ISR22 tab here, and you see here, this is a place where the first time our application received the button interrupt. When the application received the button interrupt, task 2 was executing first. Let's analyze this. So here it is. This is a button interrupt, and button interrupt, what it does, it just sets the flag to 1. That's it. And after that, it exits. When it exits, the old task continues. And after that, so this is a place at which the priorities got exchanged. Here it is. So you can see that the task 2 actually calls v task priority set for the task handle of task 2. So here it is, the first v task priority set. Here task 2's priority is set to 2, priority 2, and after that here there is one more v task priority set for task 1. Task 1's priority is now raised to 3. That's why this API actually triggers the context switch. So that's the reason, because its priority is now higher than the currently executing task, that is task 2. Now task 1 is of higher priority, so that's why the context switch happens to task 1. Like that. That's how task 1 continues here. And here is the next interrupt, and task 1's priority is lowered and task 2's priority is raised. So that's why task 2 runs here. Try this at your desk and let me know if you have any issues. I'll see you in the next lecture.